With this video, we'll start a new topic, motion. We all see birds flying, people walking, animals walking. All these examples comes under motion. Anything that has a movement attached with it has a motion. I've taken 3 examples here. The first one is a 100-meter race. In 100-meter race, participants are required to run straight on a 100-meter track. This comes under straight line motion. The second is a merry-go-round. Merry-go-round is an example of a circular motion. And the third example is an amusement park ride, which is an example of oscillatory motion. To begin with, let's start describing motion. We describe the location of an object by specifying a reference point. For example, if I say school is 2 kilometers north of railway station, we say that if this is the railway station, my school will be somewhere here 2 kilometers north. Similarly, to describe the position of an object, we need to specify a reference point called origin. Stadium is 3 kilometers north east of my house. Here, my house will be the origin and the stadium will be 3 kilometers northeast of my house. So this will be 3 kilometers, this will be the northeast direction, this will be my home, and this will be my stadium. Now we move forward to motion along a straight line. Suppose a participant starts from position A along a straight line. First, the participant goes from A to B, then goes from B to C, then goes from C to D, and finally comes from D to B. In this example, the total distance covered is 10 plus 10 plus 10 plus 20. That will be equal to 50 kilometers. Now here we define a term displacement. Displacement is the shortest distance measured from initial to the final position of an object. Here the final position of object is position B, the initial position of object is position A. So the shortest distance between these two positions is 10 kilometers. So the displacement in this example, displacement is equals to 10 kilometers. Now, motion can be uniform motion or non-uniform motion. When equal distances are covered in equal interval of time, it is defined as uniform motion. Similarly, non-uniform motion is defined as unequal distances covered in equal interval of time. Now measuring rate of motion. To measure rate of motion, two quantities are used, namely speed and velocity. Speed is defined as the total distance traveled divided by total time taken. It can be constant or variable. So, speed is total distance divided by total time. Similarly, velocity is speed with direction. Velocity is defined as the net displacement divided by the total time taken. Same as speed, velocity can be constant or variable. So, velocity is equals to net displacement divided by total time. In case of velocity of object is changing at uniform rate, then velocity is given by the arithmetic mean of initial velocity and the final velocity for a given period of time. So let's say we have point A and we have point B. An object starts moving from point A to point B. Initially the object has a velocity u, and when it reaches point B it has velocity v. So with this statement, what we say is average velocity is equal to initial velocity plus final velocity by 2. That is the arithmetic mean of initial velocity u and final velocity v. Now let's take a question to understand the concept we learned. Suppose a person runs on a 200-meter track of 100 meters by running from starting point to the finishing point and back along in a straight line in 2 minutes. calculate his average speed and average velocity in meters per second. So we have been given that a person starting from point, suppose A, to point B on a 100-meter track first goes from A to B, then comes back from B to A. In this process, the distance covered is equal to 100 meter plus 100 meter. So 100 plus 100 equal to 200 meter. And the net displacement, that is the initial position minus the final position, is 0 meters. So the speed will be distance traveled upon total time taken, that is 200 meters upon 2 minutes. Now we have been asked to calculate in meters per second. So we convert this minutes into seconds. So 200 meters upon 2 into 60 seconds. So our answer will be 200 upon 120 meter per second. Similarly, velocity is equal to total displacement, that is 0 meters upon 2 minutes, which is equal to 0 meter per minute, or which is same as 0 meter per second. It doesn't matter because it is 0. In our day-to-day life, the motions that we encounter are generally non-uniform motions. In non-uniform motion, velocity varies with time. It has different values at different instants and at different points of the path. Thus, the change in velocity of the object at any time interval is not zero. We define a new physical quantity called acceleration. Acceleration is equal to rate of change of velocity with respect to time. That is, acceleration A is rate of change of velocity, final velocity minus initial velocity upon time taken, which is v minus u upon t. The SI unit of acceleration is meter per second square. Because the unit of velocity is meter per second, and then again we divide it by time second, it becomes meters per second square. We need to understand this acceleration thoroughly to define non-uniform motions. For this, we take a question. Starting from rest, Ramesh drives his bike to achieve a velocity of 6 meters per second in 3 seconds, and then applies brakes to bring down the velocity to 4 meters per second in another 3 seconds. Calculate the acceleration in both cases. So, case 1, when Ramesh is accelerating his bike, what he is doing is initial velocity is equals to 0 per meter per second because he is starting from rest. Then final velocity is equal to 6 meters per second as given in the question, and time taken is 3 seconds. Therefore, acceleration in this case will be 6 minus 0 upon 3 meter per second square, which will be 2 meter per second square. In the case 2, his velocity initially is 6 meter per second because the final velocity that he achieved in case 1 will be his initial velocity in case 2. Here the final velocity is 0 meters per second because he brings down 4 meters per second because he brings down the velocity to 4 meters per second, and the time taken is 3 seconds. Therefore, the acceleration is final velocity 4 minus initial velocity 6 upon 3, which is minus 2 by 3 meter per second square. What we see here is acceleration can be negative. Thus, we see that velocity as well as acceleration can be negative or positive depending upon the situation. In the next video, we will learn about graphical representation of motion and uniform circular motion. Thank you.